So again, we finished example 2A. We're going to move on now to 2B. All right, example 2B is telling us in the directions to start by putting in matrix A and then adjoining it with the identity matrix I. And so what that means is this. Matrix A, remember your note should be in front of you, it would look like this. And then we're going to adjoin matrix A to matrix I. And that's just the identity matrix, which looks like this. And now what we're going to do is Gauss-Jordan elimination to rewrite this 2x4 matrix as this matrix. This new matrix where now, in this new one, your identity matrix comes first. So let's see how that works. Well, we have to know Gauss-Jordan elimination method, all right? A concept we talked about back in section 5.2. So we need to make sure our first entry, our 1-1 entry is a 1, and it is a 1 already. So because this is a 1 already in our 1-1 entry, we now want to do what? We want to zero this out. Think about it. We want our first 2x2 square matrix right here to end up looking like this. All right, so this has to be a 1 and this has to be a 0. Okay, so how are we going to make this a 0? Do you remember what to do here? First thing we're going to do is write down the row that needs to change. So the row that needs to change is the second row. This needs to become a 0. Then write down the opposite of this number, plus 1, is the opposite of negative 1. And then you're going to be multiplying that by the row that contains your pivot entry. In this case, it's row 2. So what do we get? Well, here is what we get. First row stays exactly the same. The row that's changing again is row 2. So what's going to happen? All right. It's going to be the sum of these two values, which is going to be 0. That's the whole point. And then it's going to be what? 3 plus 1 times negative 2. That's going to be a 1. And then moving on to column number 3. 0 plus 1 times 1 is 1. Performing the row operation one final time in column 4. 1 plus what? 1 times 0, that's 1. Again, you can use your calculator if you so choose to perform these row operations. All right, so we've completed our first column. The second thing we got to do is what? Well, we have to make sure we have a 1 in our 2 entry, and we do already have a 1 there. That's nice. So all we have to do now is perform one more row operation. That will do what? That will zero out this negative 2. All right, do you see it transforming? Again, we want a diagonal of 1s and 0s everywhere else. So we have to perform one more row operation in order to achieve that goal following these directions. All right, so we got to change row 1 now, right? So row 1 is going to change. And what we're going to do is write down the opposite of this number because we want that to become a 0. So that's a 2. And then we're going to write down right next to it, multiplying it by what? The row that contains our pivot entry. Okay, so let's see if we can knock this out, finish up example 2B. All right, so row 1 is going to be changing. 1 plus 2 times 0. 1 plus 2 times 0 is just 1. Very good. Negative 2 in row 1 plus 2 times 1 is 0. Perfect. That's the whole point. Over here we get what? 1 plus 2 times 1. 1 plus 2 times 1 is 1 plus 2 or 3. Here we get 0 plus 2 times 1. That's 0 plus 2, which is 2. All right, row 1 complete, and then we're not changing row 2 at all, so we have finished. Okay? Again, we have changed this first 2x2 square matrix into the identity matrix, leaving us with what? The inverse of matrix A right here. So we already knew what the answer is going to be. We just did this in example 2A. But what we're doing is we're learning different techniques. in order to come up with the same result. Because directions will matter. We have to be able to follow the directions. All right, let's move on to example letter C. So we've completed letter B. Now let's move on to letter C. There's an asterisk here because we're only able to use this technique if we have a 2 by 2 matrix. So here is how using the determinant of A will work. This value right here, this product AD minus this product BC, this is actually the determinant. All right? So all we have to do, if we're given matrix A, define the inverse of matrix A, is rewrite it like this. This only works if the determinant does not equal 0. I mean, that should be obvious because if the determinant is equal to 0, beep, 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 you're getting an undefined situation. So if that happens, if you get an undefined situation here, which means your determinant is equal to 0, then your matrix is singular. In other words, it will not have an inverse. Okay? So get this down. You want to know how to do this. All right? Definitely memorize this model. Okay, let's see how it works. Okay, so again, 2C. We have to use the determinant of this matrix A in order to come up with the inverse of matrix A. So how does that work? Well, remember this. Remember this, all right? So let's go ahead and apply it now. All right, so based on this information, the inverse of matrix A is going to be equal to what? 1 over what? A times D, that's 1 times 3, minus B times C. What did I just point to? B times C is right here, folks. B times C, all right? So minus what? In this case, negative 2 times negative 1, all right? This is actually your determinant. Okay, then we're going to multiply it by what? We have to change some things around here based upon this notation. So what are we doing? Well, we're going to put this D value in the 1, 1 entry. Then we're going to write down the opposite of this 1, 2 entry. We're going to change B to the opposite of what it was. So the opposite of negative 2 is positive 2. We're also going to make this the opposite of what it was. Your C entry will become the opposite, in this case, of negative 1, which is positive 1. And then what used to be here in the A position of your original matrix is now going to move into the 2, 2 position, giving us that. All right. That's all you're doing. You're just plugging in numbers and then simplifying the result. Okay? So what do we get? Well, we get what? 3. This is challenging. A negative times a negative times a negative is a negative, negative 2. So 3 minus 2, folks. 3 minus 2 is 1. And we knew that was going to happen because you should have already recognized that this is our final result. All right, so therefore, the inverse of matrix A using the determinant of A is 3, 2, 1, 1. Again, all the answers are going to be the same. What we're doing is exploring different ways to find the inverse of a given matrix.